In this section 10.4, we'll talk about hypothesis tests for population standard deviation. So the objectives in this case will be to test a hypothesis about a population standard deviation. And so the main thing that we're going to use in this case will be the chi-squared distribution, which we talked about back in chapter 9. And so if you have a simple random sample of size n is obtained from a normally distributed population with a mean mu and standard deviation sigma, then chi-squared, where s squared is the sample variance, this distribution has a chi-squared distribution with n minus 1 degrees of freedom. So to remind you about a couple things about the chi-squared distribution, remember that it's not symmetric, right? The shape of the chi-squared distribution depends on the degrees of freedom. As the number of degrees of freedom increases, the chi-squared distribution becomes more nearly symmetric and normal. And then the values of the chi-squared are always non-negative, right? They're greater than or equal to 0. And so you can see what the shape of the chi-squared distribution becomes with greater degrees of freedom. You can see that it becomes more and more normal here. And so so the first objective in this case, and the only objective I guess, will be to test the hypothesis about a population standard deviation. So as far as testing hypotheses about a population variance or standard deviation, to test the hypothesis, in this case, we can use the following steps. So provided that, again, the following conditions are met, and that is that the sample is obtained randomly and the population is normally distributed. And the procedure for this is listed on the top of page 509 and the top of 510 in your book if you want to take a look at that, and these two conditions are mentioned there. So these would be the various steps. So step 1 would be to determine the null and alternative hypothesis. And again, in this case, you should either have a two-tailed test, left-tailed test, or right-tailed test. Notice in this case, what we're comparing here is the standard deviation, though, and not the mean or the population proportion as in previous sections. So step 2 is select a level of significance. Again, this will typically be 5% unless otherwise stated. Compute the test statistic would be step 3. And then again, the third step depends, or the fourth step depends again on whether you want to use the classical or p-value approach. With the classical approach, again, you'd want to use table, in this case 7, to determine the critical values using, again, n minus 1 degrees of freedom. So again, you could have a two-tailed test like this. Now, just keep in mind these are not symmetric, so if, for example, you find chi-squared of alpha over 2, you can't just double it to get the area here. You'll need to calculate these two things separately and then add them together. For a one-tailed test, right, it's 1 minus alpha. For the two-tailed test, if your test statistic winds up in this critical region, then again you would reject the null hypothesis. So this is very similar to what we saw in the case with the sample proportion and sample mean. And again, if you're going to use the p-value approach, again you would just compute the probability. And again, in this case, it's recommended that you use technology to calculate the p-value, since this may be difficult to look up in the table. So again, you can have left or right-tailed approach. Again, you might need to calculate these separately. And then again, if the p-value again is less than alpha, you will reject the null hypothesis just as in previous tests. And then don't forget to state the conclusion, as always. So again, the word of caution, the procedure in this section are not robust. Therefore, if analysis of the data indicates that the variable does not come from a population that is normally distributed, then you should use non-parametric tests, which we'll talk about in chapter 15. So again, you shouldn't really have to worry about that in this section. You can assume that the population is normally distributed or that the conditions are met in most cases. But just something to be aware of. So just to do an example here, let's say that So, you know, a typical can of 7-Up states that the contents of the can are 355 milliliters. And let's say you're a quality control engineer working at a say a 7-Up plant filling bottles, and so you're concerned that the filling machine is miscalibrated. So you randomly select 9 cans of 7-Up and measure the contents. So in this case, you can see that they're not all exactly equal to this. So in section 9.2, we assume that the population standard deviation was 3.2. We want to test the claim that the population standard deviation is greater than 3.2 at this level of significance. So again, set up your null and alternative hypothesis. So this will be a right-tailed test. Here's your level of significance. From the data, we can compute the test statistic, which is given by this. So you have 9.374. And then again, we can either use the classical or the p-value approach. So using the classical approach, you would want to compute the, since it's a right-tailed test, you want to compute chi-squared for 0.05 with 8 degrees of freedom. They'll give you about 15.507. And since the test statistic is less than this value, it's not in the critical region, it's not to the right of this value, then we will fail to reject the null hypothesis. Again, using the p-value approach, we should be able to come to the same conclusion. So in this case, the probability that chi-squared will be greater than 9.37 is greater than 0.01. And since the p-value is greater than the level of significance, again, we will reject the null hypothesis. And again, you could use StatCrunch to find the exact value if you don't want to use the table. So step 6, then, there is insufficient evidence to conclude that the standard deviation of the can contents is greater than 3.2 milliliters. So I guess there's no real need to recalibrate the machine. Right, well, that pretty much finishes up section 10.6. The next section, 10.5, deals with kind of putting all this stuff in the previous sections together, you know, determining which method to use. Maybe just to give you a preview for that section, you know, it will largely depend on what you're measuring, right? If you're measuring the proportion, you'd want to use this test statistic. If you're using the mean, you'd want to use this test statistic. If you're figuring sigma or sigma squared, you'd want to use this test statistic. One thing I should maybe mention also in this last section is that if you are dealing with the, instead of the standard deviation, if you are dealing with the variance, right, you might need to square your p-values. So just something to keep in mind. Right, well, I hope that helps. So